Every day, millions of hands twist open a plastic bottle, believing the water inside is pure and untouched. The clear liquid looks clean, the sealed cap feels safe, and the label promises freshness. But behind that simple design, scientists have been asking a different question. What if the bottle itself quietly changes what is inside the water over time? Over the past decade, researchers studying drinking water have discovered details that rarely reach everyday conversations. Tiny particles, trace chemicals, and subtle changes that the human eye can never see. Individually, these findings may seem small, but together they reveal a story that many people never hear. A story about packaging, storage, and what really happens to water once it is sealed inside plastic. And once you discover what researchers have actually detected in some bottled water, that simple clear bottle sitting in your hand may start to feel a little less innocent. Let us discuss one by one. Every sip of bottled water carried something you could never see with your eyes, something so tiny that it slips into the water without changing its taste, color, or smell. Scientists call these particles microplastics. They are extremely small fragments of plastic that can break off from packaging materials. In recent years, researchers started testing bottled water to see if these particles were present, and what they discovered surprised many experts. Scientific studies have detected microplastic particles in a number of bottled water samples. These particles can originate from the plastic bottle itself, from the cap, or even from the bottling and packaging process. One widely discussed investigation, led by Sherry Mason at the State University of New York at Fredonia, examined bottled water brands and reported the presence of microplastic particles in many samples. This discovery drew global attention because bottled water is commonly viewed as one of the purest drinks available. The issue has also been examined in scientific discussions and reports by the World Health Organization, which has reviewed the growing research on microplastics in drinking water. But here is the part that really captures attention. The concern is not simply that plastic fragments exist in water. The deeper question scientists are trying to answer is what happens when extremely tiny plastic particles enter the human body again and again over long periods of time. Because these particles are incredibly small, people may drink them without ever noticing anything unusual. The water still looks perfectly clear, the taste remains the same, and nothing seems different at all. Yet at a microscopic level, a hidden element may already be present. And this discovery opens the door to an even bigger question about bottled water, because microplastics are only the first hidden detail researchers have uncovered. Under certain conditions, the bottle itself may also release other substances into the water. Have you ever left a bottle of water sitting inside a hot car, on a sunny dashboard, or in direct sunlight during a warm afternoon? It seems harmless. The bottle looks exactly the same. The water still appears crystal clear. But scientists have been studying what actually happens to plastic bottles when heat enters the picture, and the results are more interesting than many people expect. Plastic bottles used for drinking water are commonly made from PET plastic. Under normal conditions, they are considered safe for use, but research has shown that heat can increase the movement of certain chemical compounds from the plastic into the water. This process is called chemical migration. When bottles are exposed to higher temperatures during transportation, storage, or long hours in the sun, tiny amounts of substances from the plastic material may slowly move into the water. Environmental studies and safety discussions from the Environmental Protection Agency have examined how temperature can influence interactions between packaging materials and liquids. Environmental health researchers have also explored this topic for years. For example, public health scientist Philip Landrigan has frequently discussed the broader concerns surrounding long-term human exposure to plastics in everyday products. But here is the part that often surprises people. The water placed inside the bottle at the factory may begin completely safe and carefully tested. Yet after weeks of storage, transportation across long distances, and possible exposure to heat, subtle changes can slowly occur at a microscopic level. Nothing about the bottle warns you. The label still looks the same. The water still looks pure. Yet chemistry does not always remain frozen in time. Storage conditions can quietly influence what happens inside the bottle. And once scientists began looking closely at these interactions, they uncovered another hidden factor related to plastic packaging that many bottled water drinkers have never heard about. Plastic bottles look solid, smooth, and perfectly stable, but on a microscopic level, they are constantly interacting with the liquid they hold. The material used in most bottled water containers is known as PET plastic. It is widely used around the world because it is lightweight and durable. However, scientists studying food packaging have discovered that plastics are not completely inert. Over time, very small amounts of certain compounds can migrate from the plastic material into the liquid stored inside. This process is known as chemical leaching. One substance that researchers often examine in bottled water studies is antimony. Antimony is used during the manufacturing process of PET plastic, and scientific studies have shown that trace amounts of this element can slowly migrate into water stored in PET bottles. Research published in environmental chemistry journals has examined how antimony levels may increase slightly when bottled water is stored for long periods or exposed to higher temperatures. These findings do not necessarily mean bottled water is unsafe, because regulatory agencies set strict safety limits for these compounds, but they do highlight an important scientific detail that many people never think about when they pick up a bottle of water. And here is the surprising part. When people think about drinking water safety, they usually focus on the source of the water itself, wondering whether it comes from a spring, a mountain, or a municipal supply. Yet scientists point out that the container holding the water can also become part of the equation. The bottle is not just a passive container. At a microscopic level, it can interact slowly with what is inside it. And even when these chemical levels remain within regulatory safety limits, researchers continue studying another hidden issue connected to plastic packaging that has raised growing attention in recent years. Plastic packaging used for food and drinks is carefully designed to meet safety standards, yet scientists often remind us that no packaging material is completely inert. On a microscopic level, materials that hold liquids can slowly interact with what they contain. This is why researchers study something known as trace compound migration. Over time, certain plastic packaging materials may release extremely small amounts of chemical compounds into liquids stored inside them. These levels are usually very low and are strictly controlled by regulatory authorities, but scientists still examine them closely to understand how packaging materials behave during long storage periods, transportation, or changing temperatures. Food safety researchers have studied these interactions for decades because packaging plays a major role in protecting the quality of food and drinks. Organizations such as the Food and Drug Administration in the United States and the European Food Safety Authority in Europe regularly evaluate packaging materials and set limits to ensure that any compounds migrating into food or beverages remain within safe levels. But here is an important point that often gets misunderstood. The real message behind these scientific studies is not panic or fear. Instead, the goal is awareness and careful monitoring. Scientists want to understand exactly how materials interact with the products people consume every day. When something is used billions of times around the world, even small details become important to study. And that is why packaging science continues to evolve as researchers gather more data about long-term exposure to very small amounts of compounds. The real takeaway from all of this is awareness, because the water people drink every day deserves thoughtful attention. And once these hidden factors become clearer, everyday choices about drinking water may start to look a little different. Water is one of the most essential things the human body depends on every single day. It fuels the brain, supports every organ, and keeps the body functioning the way nature designed it. But sometimes the conversation about clean water focuses only on the source, while the container quietly escapes attention. Scientists around the world continue studying the subtle interactions between plastic packaging and the water stored inside it, not to create fear, but to understand the small details that can influence everyday health. The reality is that knowledge gives people power. When we understand how our daily habits connect with science, we begin to make smarter and more thoughtful choices. And in the end, the goal is simple awareness, because when it comes to something we drink every single day, informed decisions will always protect health better than assumptions. Like and share if you have gathered some fruitful information from this video.